Well, in this video, we've got our final two examples of graphing rational equations or rational functions. So the first thing I'm going to do in this example is draw the asymptotes. So first, let's look at VA, the vertical asymptotes. How do you find the vertical asymptotes? You set the denominator equal to 0. So x squared minus 25 equals 0, and then solve for x. Well, that means x squared minus 25 is 0, means that x squared equals 25. X squared is 25, and that means that x is equal to plus or minus 5. I think I'm going to write them separately. X equals 5, x equals negative 5. Two vertical asymptotes. So remember, now we know what the domain of this function is. The domain is every single real number except for these two. These are the only two that would give you a 0 in the denominator. So let's go to 1, 2, 3, 4, 5. I want them to be visible. Hopefully you can see that. It's supposed to be a vertical dashed line. Doesn't look much like it. 4, 5, and then another one. Another one right there. Okay, x equals negative 5, x equals positive 5. The two vertical asymptotes. Now let's go for the horizontal asymptote. Well, we have to look at the degrees of the top and the bottom, and they're equal to each other. So the horizontal asymptote is y equals 2 over 1, the coefficient of the numerator over the coefficient of the denominator, looking at the leading terms. So that's going to be y equals 2. All right, so that looks like that. Okay. All right, so we got our asymptotes done. Now notice, the vertical asymptotes break the xy plane, or the xy plane into 3 sections. To the left of this, in between the two asymptotes, and to the right of this vertical asymptote. So we're going to have to plot some points in this section, and this section. And since we're dealing with a function here, we know it's either going to be all up here or all down here. All right, and since all these are asymptotes, whatever we draw up here or down here, I don't know where it's going to be, it's going to have to hug these two, like this wall and this floor, or this ceiling and this wall. In the middle, it could be, there's several ways it could go. It's going to use both of these vertical asymptotes. It could go like this, and then down this way and hug them both that way, or it could go this, hug them both that way, or it could be that it's all up here, or it's all down here. And then similarly on the right, it could be over here, or it could be all down here, hugging these two asymptotes, or these two. All right, so let's just plug in some points. Now, there is something special about this graph, in that, or this function. Let's make an xy table. I'm not going to do very many points, and you'll see why in a minute. I'm going to do about 4 points, I think. First, let's plug in 0. What do we get? If we plug in a 0, the x's are 0, we get 5 over negative 25. We get negative 1/5. So that's one ordered pair. So now let's try maybe something like a 4. I want to get another one in between 0 and this vertical asymptote. I don't know if it's going to be up here or down here. Let's plug in a 4. And let's see. That's going to be 2 times 16, 32. Plus 5 is 37. I'm going to use my scratch paper down here. 37 over, when I plug a 4 into the denominator, I get 16 minus 25 for negative 9. That is negative 4 and 1/9. Okay, let's do maybe 6 and then maybe 10. All right, so when we plug in a 6, upstairs I'm going to get 36, because that's x squared, times 2 is 72, plus 5 is 77. And 6 on the bottom is going to give me an x squared 36 minus 25, which is 11. And that's equal to 7. And then finally plugging in a 10, that shouldn't be too hard. 10 squared is 100. So that'd be 200 plus 5, 205, over, plugging a 10 in the denominator, 100 minus 25 is 75. So let's see, if we divide those by 5, we would get 41 over 15, I believe. 41. Let me try that one more time. Plugging in 10. 100, 205 over 10. 100 minus 20, 75. Okay, so that is roughly speaking 41 over, we divided that by 5 to get 15. That's about 3, not quite 3. 2 would be 30 with the remainder of 11. And 11/15. 2 and 11/15. Okay, so why am I stopping here? The reason is this is an even function. And you don't have to remember that term if you don't want to. But what's going to happen if I plug in a negative 10 here? Well, the negative 10 is getting squared. Here, the negative 10 is getting squared. I'm going to get exactly the same value as if I plug in a 10. If I plug in a negative 6, I'm going to get a 7. If I plug in a negative 4, I'm going to get a negative 4 and 1/9. So all I'm going to do is plot some points on the on the x-axis from 0 to the right. And then we can just do the mirror image on the left. It's going to be symmetric about the y-axis. All right, so the first point, 0, negative 1/5. I'll go ahead and just to show what we're doing here, I'll make them ordered pairs. Negative 1/5, that's about right there. 4, negative 4 and 1/9. Okay, 4, 1, 2, 3, 4. 1, 2, 3, 4, just a little beyond negative 4. 6, 5, 6, it's going to go 1, 2, 3, 4, 5, 6, 7. And at 10, we get 2 and a fraction. 1, 2, 11/15 is pretty close to 1. So it's going to be 2 plus the 11/15. So I already know now what's going on up here. This point and this point, it's just going to go like this. And it's going to hug this kind of as a wall. And then it's going to go here and hug the horizontal asymptote, kind of like a floor, like that. And now I'm going to go ahead and do the mirror images. I'm going to use a pin that works a little better for the graph. And then down here, we've got the mirror image of this would be negative 4, right about there. And this is just going to go something like this. And that's what the graph looks like. Notice that each section is hugging the asymptotes. Now this one's not hugging the this asymptote, the horizontal asymptote, but it doesn't have to. The horizontal asymptote is only for when x goes towards infinity or towards negative infinity, and this section is trapped between these two vertical asymptotes. So it's going to hug both of these walls. This one hugs this one, and this one up here hugs that one. Okay, let's move on to our final example. Given here, for this one, f of x is x minus 3 on top, and then x squared minus 3x minus 10 on the bottom. And don't know if it's going to help or not, but I'm going to go ahead and factor the bottom. X, we need a plus and a minus. I have to multiply to negative 10 and add to negative 3. So it would be the minus 5 plus 2. Now that helps us out by finding the vertical asymptotes. It's very simple now. Setting the bottom to 0, we'll set this to 0, and we can tell that our vertical asymptotes will be x equals minus 2, negative 2, and x equals positive 5. Let's go ahead and draw those. Let's see, negative 2. And positive 5, 1, 2, 3, 4, 5. Okay, we've got our two vertical asymptotes. Now let's take a look at the horizontal asymptote, and there is one. And actually this one's pretty easy. What we look at is the degree of the top and the degree of the bottom. The degree of the top is 1, it's like x to the 1, and the degree of the bottom is 2, like x squared. Well, since the degree of the bottom is bigger than the degree of the top, remember that the horizontal axis is just the line y equals 0, which is the x-axis. So here we go. All right, so we have our one horizontal asymptote and two vertical asymptotes. Now let's plot a few points. Let's start with a nice easy one, 0. What is f of 0? Well, if x is a 0, we're going to get negative 3 over negative 10, or 3/10. So let's see where I can write these. I'll write this 0, 3/10. That's one ordered pair, and I'll go ahead and plot it. 3/10, it's just a little less than a half, or a little more than a quarter. So it'd be about like that. And how about a real easy one? 3. F of 3 is going to give us a 0, right? 3 minus 3 is 0. So 3, 0, we found our x-intercept, and by the way, that is the only x-intercept. If you set this equal to 0, the only way you can get a 0 is if x is a 3. So let's remember, I'm plotting the only x-intercept right here. All right, let's move on to maybe a number like 6. Maybe I'll do 6 to get on the other side of this, and then 10. F of 6 will be 6 minus 3 is 3. 6 squared is 36. Minus 18. Minus 10. Let me do that one more time. 36 minus 18 is 18. Minus 10 is 8. Does that sound right? 6, 3/8. So 3/8 is a little bit less than a half. So when I go out to 6, it's going to be just a little less than a half. Like that. And if I plug in a 10, 10's usually easy to do. 10 minus 3 is 7 on top. 10 on the bottom. 100 minus 30 minus 10. 100 minus 40 is 60. And that's pretty close to 1/10. 6 over 60 would be 1/10. It's a little bit more than 1/10. Let's put that right about there. And we know what it's going to look like. It's already really hugging that. Let me use a better pen. It's already hugging that the x-axis, and now it's going to hug the y-axis. Okay. All right, now this is not an even function, so we have to plot points over here as well. But let's do, maybe I'm going to do one more point in the middle just to see what goes on here. I don't know if it's going through or if it's going to stay down below here. So I'm going to do this point right here, 1, 2, 3, 4. Let's do f of 4. F of 4 is going to be a 1 on top, 16 minus 12 minus 10. 16 minus 12 is 4, minus 10 is minus 6. So it's going to be 4, negative 1/6, so barely below the x-axis. So since we know it never crosses the x-axis again, we know basically what it looks like down here. Get the other pen. And again, this doesn't have to look symmetric. And it won't. So the inside looks something like that. And now the left side probably will be either up here or down here. We will see. Let's plug in some negatives. F of negative 3, say. So we're going to here, x negative 3. So negative 3 minus 3 is negative 6 over, that would be a 9 plus 9 minus 10. So f of negative 3 is equal to negative 6 over 18 minus 10. Negative 6 over positive 8. Negative 6/8 is negative 3/4. So negative 3, negative 3/4. 1, 2, 3. Negative 3/4 will be down about here. All right, let's do maybe one more. We know what it's going to look like. It's going to hug this horizontal asymptote, and it's going to hug this vertical asymptote. Let's do one more, f of, say, negative 10. Let's go all the way out to x equals negative 10 and see what we get. Negative 10 minus 3, negative 13. Okay, negative 10 squared is 100. Negative 10 would give us a plus 30 minus 10. That's equal to negative 13 over 120. So if it were negative 12 over 20, it would be negative 1/10. So it's going to be close to negative 1/10. So when we go out to negative 10, let's see, this would be, I'll just write negative 13 over 120. So it'll be about this number right here. Oops, a little higher, really close to the x-axis. All right, so this is going to look like, this is going to have a fairly sharp-looking turn downward. And that's what the graph looks like. Again, Because of the asymptotes, we only had to plot 1, 2, 3, 4, 5, 6, about 6 points. If we didn't do that, we would have had to plot quite a few more. So that's our final example of graphing a rational function.